Welcome back to Josh Does Math. In this video, we're going to be working with some derivatives. So find a function of x whose derivative is the given function. In other words, each of these functions right here is a derivative, and our goal is to find the original function that resulted in these derivatives right here. So for the first one in the upper left here, you can see that the derivative resulted in x squared. So just thinking about the power rule says that you have x to some power, you pull the power out front, and then you make the power 1 smaller up there. So we would have originally had to start with some function like this. And then you do power out front, 1 smaller on the power, and you get that, which is exactly the same function as the one right here. So as you can see, the original function for the first one was x to the third power. We just happened to guess correctly knowing the power. Well, how about this other one over here? Just like with the previous explanation, we know that x needs to be to the third power, so that whenever you use the power rule, pull the power up front and make it 1 smaller, you get x squared. So we know that it has to be x to the third. Well, what happens whenever we pull the power out front and make it 1 smaller? Well, we get 3x squared. That's pretty close to 4x squared. However, it's missing a coefficient of what in front? Well, it's going to be 4 over 3 x squared, or 4 over 3 times 3 x squared. That gets us back to 4x squared. So this coefficient out front, if the original function had that coefficient out front, you would do the power rule, pull the power out front, cancel with that 3 in the denominator, and you'd just be left with a 4, and it would be 4x squared. So as you can see, this is the original function, 4/3 x to the third. And for this final function down here, we can do the same thing. We're just going to be doing it to each term. So for each term, I'm going to make the power 1 bigger, because that's a good first step. Now for the first term, imagine if I were to differentiate x to the third, I'd get 3x squared. And that's exactly what this is up here. So we're perfectly fine just leaving this at 3x squared. How about the second term? X squared. If I were to differentiate that and get back up to this original function here, I would get 2x, and that's exactly what this term is right here. So we're fine. How about this last term right here? If I were to differentiate this, negative x, I would get -1. However, that's not what we have up here. We have -5. So what if this was -5x? If I were to take the derivative of this, power out front, 1 smaller on the power, I would just get -5. And that's exactly what we see up here. So this is the derivative of that original function. So for these problems, we were working backwards from the differentiation. Instead of taking the derivative of something, we have the derivative, and our goal is to find the original function. So you could maybe call this anti-differentiation, but this is just an introductory problem to working backwards once you have found a derivative. Thanks for watching.